Good evening all. I'd like to welcome you to Riverside University Design Challenge webinar series. This is week 1, webinar 2, sustainable construction. So it's sustainable timber and off-site manufacture we're looking at tonight. Tomorrow night, we will be looking at counting carbon, and on Friday, we have a virtual pub. Be lovely if you would come and join us. So tonight's speakers are going to be Richard Gore from NETTA, myself, Alun Watkins, Charlie Law, Iain Thew, Professor Robert Hairstans, and Mila Duncheva. So I'm Tabitha Binding. I'm going to be your program manager throughout the length of this competition. And I'd like to hand you over to Richard Gore, who's Head of Education at NETTA, which is the North East Timber Trade Association, which is one of the Timber Trade Federation's regions. Can I hand over to you, Richard?
Thank you very much, Tabitha. Yes, thank you. I think we'd like to say that we in NETTA are delighted to lend our support to this Design Challenge project. I was intrigued by the word challenge, very well chosen in my view, as those working on designs for the centre of Sunderland have much to contend with and take into account over and above the considerations we've been told were the yardsticks of previous generations. I think for those young people who are designing, factors considering living space and how to incorporate all the amenities we all take for granted are probably run of the mill. But when you add to that the inclusion of everything that will enable the buildings to be in line with what is desperately needed to help the world and the UK, in this instance, become CO2 free, and all that will entail is, by standards of history, quite a recent complication. The using of materials that are sustainable and fit the other criteria may seem daunting, as some of the older materials will not be applicable, in my view, for this project. In NETTA, North East Timber Trade Association, we have long been proclaiming the virtues of sustainable materials and have embraced this culture for a very long time. NETTA is the North East Timber Trade Association, as I've said, and in our title is the word for the product that we, as an association, work with every day. Timber starts in the forest and ends up in buildings, as obviously you know, and we in our membership have every link in the chain from sawmillers to manufacturers that bring this product through to builders and eventually to the public. All the membership realise the necessity and value of using sustainable resources, in this case wood. It is perhaps obvious, but nevertheless true, that it is a commercial common sense to replant more timber resource than you extract. I think a classic example of this is in Sweden, and you may not know that for many years Sweden have harvested less fibre than they grow, despite having a very large timber consuming industry. Most other countries surrounding the Baltic Sea have a similar ethos. Our membership are able to provide the market for building from garden sheds, timber lodges to housing projects with an array of timber-based products from C24 grade joists, joinery timbers for windows and internal fittings, plywood, MDF, chipboard, all of which come from sustainable resources. To ensure we all abide by the rules, our friends at PEFC and FSC, one of whom you'll hear from later on, have developed systems to ensure that this happens and carry out regular audits on companies who adhere to these principles. All the products I'm aware of that are sold by our membership are covered by one of these organisations, and they will have the relevant paperwork to prove that they're offering materials that come from verifiable, sustainable forests. We think the Sunderland project is innovative and exciting as it looks into the future and will be a great influence on good planning regarding city centre regeneration, which is so badly needed throughout the UK. I think those of the north of England are particularly aware of that. NETTA is part of the TTF, and we'd urge all of you to use the resources of the TTF, TRADA, STA, BWF, and any other organisation that's giving lectures in these webinars, as they have a wealth of information about products that you will wish to use in your designs, and I'm sure they'll be able to help you a great deal with any questions that you may have. We in NETTA wish this project every success and look forward to seeing it develop and grow and seeing the finished products in better living prospects for the great city of Sunderland, as well as providing some of the materials that will make it happen. Good luck and thank you very much. Over to you, Tab.
Thank you, Richard. So I lead the University Education and Engagement Programme for TRADA, which is the Timber Research and Development Association. We came into being in 1934, so we're not exactly a young organisation. Our activities: we provide technical information on timber, we promote wood as a material and how to use it, we do research, and we do university engagement. Most of the information we hold is either with our technical consultants, in our publications, or on our website. And students get free access. You don't go here to sign up. You head to academic, you scroll down till you hit the orange section, and you sign yourself in. You then log in and you get learning resources, case studies, wood information sheets. In the learning resources, there are 8 modules and 63 units. So if you want to start with construction principles, specification and design, this is where you head. They are all PDFs. You click on them, download them, and save them to your computers. Why choose timber? Breaks it down into deeper depths, shows you the details, and shows you all the cross sections and what is called what. But how do trees grow? You have a seed, you have some water, you have some sunlight and some earth, and up they go. They grow from the inside outwards. So if you imagine a traffic cone, imagine another traffic cone on top of that, and another traffic cone on top of that. And that's how they grow each year. Every year they grow outwards and they grow upwards. And if you see that little green shoot on the outside there, that's the branches, and that's where the leaves are, and that's what that's where photosynthesis happens. So if you look here in the middle of the screen, this is the pith, and as it grows outwards, and here's your bark. Now here you've got your light coloured growth ring, and that is your summer, or sorry, it's your early wood. The dark growth ring is your late wood, and this is as the tree growth starts to slow down. So you've got your spring through to your autumn, spring through to your autumn. So when you're aging a tree, you count only the light rings or only the dark rings. You take a choice. On the outside of each tree, there is sapwood, which sapwood starts in the middle, and every year as the tree ages and it grows outwards, that sapwood matures and turns into heartwood. Now, all sapwood is non-durable. Remember that, because we've got something to come back to in some later webinars. And this is a cross section, I want to say, of larch. And just here, this is just breaking out of a knot. And knots always start from the pith of a tree. Knots for engineers are strength reducing characteristics, but you can't have timber or you can't have trees without having knots in them, because the knots are where the branches come out from. You can grow timber to minimize the knots, but you will always have some of them. But Iain will pick up on engineered wood products later. So we've got 2 main groups when we talk about wood. We've got softwood and hardwoods. And then hardwoods is broken down into temperate and tropical hardwoods. And what feature distinguishes one from another? I wonder if anybody's brave enough to put anything in the chat box. And I can't see the chat box because I haven't got it open. What distinguishes one from the other is not what the majority of people think, it's the seeds. The softwood has a naked seed and the hardwood has a covered seed. So it's nothing to do with the branches, it's nothing to do with the leaves, it's nothing to do with the density, it's nothing to do with the durability. You come right back to the seeds. So softwoods, mostly evergreen, needle-shaped leaves, 650 species, but only 60 in commercial use. But you'll probably only use 6 to 10 of those commercial species in, in construction itself. And commercial softwood is grown as a crop. So it's planted specifically for that reason. And we have a fair amount of it. And Charlie, I'm sure, is going to pick up on that. Hardwoods, mainly deciduous, but you do have some evergreen. They are broadleaves, 50,000 species, 2,000 in commercial use, but they all have specialized end uses. So green softwood, newly felled logs can have a moisture content of over 100%. Now, some of you will be going, yeah, no, that is true or false. Anybody in the chat box want to answer that? Can you have a log with more than 100% moisture content? I'll come back to the answer. So timber is cut when it's green. It's felled. It's cut to length. It's taken through a sawmill, and this is just going through a band mill. And here is a hardwood log being milled. And when it's cut, timber is green, and it is full of moisture. But to use it in construction, or actually use it in a house, we need to dry it down. So the wood structure, on a very basic level, it looks like a whole bundle of straws. So if you imagine all these little rounds here full of straws, you'd be looking down loads and loads of straws. And there you can see it. So this is what I'm talking about. And this is the vessel inside those straws. And this is full of water. And the cell structure, the walls of those cells are also full of moisture. This is, I'll get it all wrong, it dries from within inside the cell first and then outside, out of the cell wall. So different timbers, softwoods and hardwoods, have different wood structures, but I'm not going to touch on that. I'm just saying, just letting you know that. And this is how they dry. So this is a saturated wood with the, so this is your long straw. These are your cell walls, and the dark blue in it here is your saturated cavity. As you start to dry it, it dries out of the cavity first until there is no more water within there. You then only have water or moisture within those cell walls. So you see here, this is a fully saturated cell wall. As you dry it, the moisture comes out of it and that cell wall shrinks. And so what happens to timber as it dries with the shrinkages? So this is your cross section cut through, this is your tangential side, and this is your radial section here coming from the pith. It shrinks, but it shrinks differently on different planes. Longitudinally wise, so the length of the tree trunk, it virtually not at all. The radial, so coming across here, it shrinks a little bit, but tangentially it shrinks quite a lot. And here you can see it's splitting apart as it shrinks, as it dries and as it shrinks. Is shrinkage predictable? Yes. So if you see a cross section cut here from the middle of the tree, it shrinks to this pattern. If you have a quarter sawn board, it shrinks very evenly. If you have an edge board or a falling board, it will shrink, always cupping slightly towards the center. And this is something you want to bear in mind when you're looking at cladding and actually attaching it to a building. You're always better off putting the heart side outwards, so facing outwards. So about moisture content, we talked about the wood drying out and it needing to dry out, and it shrinks as it dries out. Now I'm going to zoom through this. When you say a moisture content, it's the percentage of moisture within a fully dried piece of timber. And how do you find that out? We sort of, in our labs, we dry it down until there's no more moisture in it. And we get the weight, and then we do some calculations, and we find out what the density of that dry piece of wood is. And that's then how we work out the moisture content. But for any of you who are wanting to do it, get yourself a moisture meter, and that will indicate what your moisture content is. And so within buildings, we're looking for a range of moisture contents so that the wood doesn't shrink, and so it also doesn't degrade. Because one figure, which I unfortunately haven't got on here, is 20%. You want to keep your wood below 20% if it's inside your, if it's in construction in your building. Because at 20%, if it's held there for any length of time, it will start to degrade. And we want our buildings to last a long time. So we said shrinkage and movement is predictable, but with different species, you get different movement characteristics. So something to bear in mind when you're specifying your timber. When I mentioned moisture content and why it's important, external joinery, you're looking for 12 to 90% average moisture content. In an unheated building, you'll be looking for 12 to 16%. In a heated house, you'll be looking for 9 to 13%. And in a very nice and warm heated house, you'll be looking for 6 to 10%. And timber reacts to temperature and humidity, and it absorbs and desorbs moisture. So you can never keep it at one moisture content. It will always be adding and subtracting a little bit. But once you know where that timber is going to be, then you can predict what moisture content you will eventually settle out. And that's called the equilibrium moisture content. This is a chart we tend to use. In an average house, you'll be wanting to keep your relative humidity between 40 and 60%, because that is a healthy, I've lost my words now. That's a healthy moisture content to stay at. Let me go back one, jump one. So 20% moisture content, 20% temperature. This is the indoor equilibrium moisture contents you'll be aiming at. So 10 to sort of 12%. And we have, from those sawn logs, a huge range of products that Iain will cover later. So we have sawn timber, we have timber-based products, and we have engineered wood products. Is it sustainable? This is where I'm going to hand over to Charlie. But let me introduce you to Alun Watkins, who is the Executive Director of PEFC UK Limited. Alun.
Thank you, Tabitha. Thank you, the TRADA University Engagement Programme, for the opportunity just to say a few words before Charlie's presentation. As Tabitha said, my name's Alun Watkins. I'm the Executive Director of PEFC UK, and we're very proud to be one of the sponsors of this design challenge. PEFC is the programme for the endorsement of forest certification. Bit of a mouthful, that's why we always use the initials. And we're a global, not-for-profit, non-governmental organisation dedicated to promoting sustainable forest management. And we do that through a third-party certification, and we also work through the entire forest supply chain through what we call chain of custody to ensure sustainable timber products are delivered to the end user, including construction sites, obviously. So PEFC, we're the world's largest forest certification scheme, with over 320 million hectares certified worldwide in 48 different countries. We have about 1.5 million hectares certified in the UK, which is roughly about 50% of the forest cover, but covers most of the commercial forestry that we have in the UK. These numbers might seem fairly large, but that's still, all the certification schemes only still cover 12% of the world's forests, and that equates to about 28% of the industrial roundwood that goes into the manufacture of pulp, paper, furniture, and construction wood. So ourselves and other schemes that I'm sure Charlie will talk about still have a long way to go to ensure that there's more and more certified sustainable forest cover globally. This might be made easier by the more and more companies actually specifying certified wood. This encourages forest owners to become certified, and as I said, bring more forests under sustainable management. And that gives us lots of benefits, including preserving biodiversity, slowing climate change, storing carbon, and all the other fantastic benefits that forests give us. So hopefully you'll consider this in, I guess, your future careers, but also for this project by specifying certified timber. And also we can do that in our day-to-day lives whenever we're buying wood-based products, looking for certification or certification logos. So that's what I'm going to say. Otherwise, if I speak too much, I'll be going into Charlie's presentation. I'm sure he wouldn't want me to do that. So I'll finish just by wishing you all the best of luck in this design challenge and in your future careers, and enjoy the evening. Thank you.
Okay, thank you, Alan, for the introduction there. Yes, I'm just going to share my screen with everyone now. Get the right one. And then I can do some introductions, hopefully. There we go. Yes, so my name's Charlie Law, and we've been working with PEFC now for the last couple of years on their CPD program with architects. And what we're going to run through you today is a truncated version of that CPD that we run through. If you want to see the full presentation, keep an eye on the PEFC website under the construction section, and we do post dates on there quite regularly, and the usual presentation lasts an hour. So, but just to introduce myself, my name's Charlie Law. I'm a freelance consultant. My company's Sustainable Construction Solutions. I've worked in the construction industry now for over 30 years, most of that time at large contractors, and I was head of environmental management at one of the large contractors in the UK, BAM Construct, for many years. I also work now for a number of other organisations, really promoting timber and circular economy is where we try and focus our efforts. So today we're going to run through quickly why we need forest certification, the timber market and UK timber market and the sources of timber, because that really determines where your risks areas are. We'll look quick note on CPET and approved certification schemes, the difference between those schemes, drivers for certification. Look at what an inclusive specification clause would look like, which you should include in your specifications, and chain of custody. The one thing we won't be covering today is project certification, because we haven't got time to do that. So quickly moving on, why do we need forest certification? Well, looking at the numbers from the Food and Agriculture Organization of the United Nations, these were released end of last year, up to 2020. You can see there that we're still globally in a state of deforestation. We're losing around 4.7 million hectares of forest every year. That has slowed from its peak when they first started looking at this in the 1990s. But as you can see, we're still losing too much forest globally. So we do need to make sure that the timber that we procure for projects in the UK is from that sustainable source. Just to put a little bit more detail on there, this shows you the main risk areas. This hasn't yet been released, as far as I know, from the UN, but this gives you the idea up to 2015, which was the last set of reports that came out. And you can see there that the big issue there are still sort of places like South America, Africa, and the Far East. Brazil alone is losing around 3.5 football pitches of forest every minute. It's around 1.35 million hectares in 2018. So, you know, we do need to make sure that we try and slow that down and insist on sustainable forestry. Not all of that is down to timber. A lot of that is through land change, moving over to agriculture for things like for beef production, soya and stuff like that. So it's not all to do with illegally sourced timber. A lot of it's down to land change in those areas. So what does sustainable forest management look like? Well, Tabitha showed you some pictures, you know, earlier on. Softwood on the left, like I say, it's a crop, and generally over a 50-year rotation in a lot of cases, depending on where you are in the world. In the UK, it's generally around 50 years, and that would be thinned a number of times over that period. You know, the picture there shows a 30-year thinning, and that material would be going into things like fencing, and the remaining trees would go into your structural timbers. You see 16 structural timbers for building. On the right, it's slightly different for hardwood trees. They're generally what we call selective felling. So you'd go into the forest and you'd only take out so much every year that would allow that forest to regenerate that over a certain amount of time. So you never, in the hardwood forest, you never actually clear felling in most cases. Softwood forest you would, and you replant. Just to look at that on a higher scale, you can see here two pictures. These are 12 years apart. 2012 is the latest date, and this shows on the left what's come out of Sweden, been harvested in Sweden and Finland there, and what's regrown over that period. There's always going to be a bit of a lag between the red and the blue there, but you can see that they closely match as far as what's coming out and what's regrowing. Similarly, in the UK, a lot less forest cover in the UK. We've only got about 13% forest cover in the UK. But you can see there that where most of our forestry is located up in Scotland, a good correlation there between what's coming out and what's gone back in. But when you compare that to places like Brazil, South America generally, you can see there that there's not a lot growing back from what's been taken out. I think Chile's the only South American country that's deemed to be low risk, sustainable managed forest. So looking at the UK timber market, what does that look like? These are the latest data from the Forestry Commission. Around 70 million cubic meters of timber are consumed in the UK each year. The majority of that, like Tabitha said, is softwood. Small amount of sawn hardwood in the dark brown there, and then the remainder is panel products, things like particle boards, your chipboard, and OSB orientated strand board, fibre boards and MDFs, and then plywoods. The fibre board, MDFs, particle boards, OSBs generally made out of softwood. Your plywood generally made out of hardwood timbers, and a lot of them tropical. But when we look at where that's coming from, quite a bit of it from the UK, which some people are surprised about. The vast majority, though, is coming from the EU, and the majority of that coming from those Baltic states, Sweden, Finland, and places like that. But then we have a number of countries there where we're generally buying products from, things like plywoods and stuff like that. So China, Russia, Brazil, a range of countries there to make up that last amount. And some of those are seen as higher risk than others. So we took at things like I said before, South America, China. This is a slightly different map. This looks at legality in the supply chain. And you can see there that there's a number of countries where the legality of the trade is not as good as it could be. So we do need to make sure we manage that as we go through. So just to break down what sort of timber we're buying and where the risk areas are, you can see here that the majority of softwoods, hardwoods are from low risk countries. The key risk area in here is really plywoods, with a lot coming from China, Brazil and Russia, where we have seen either deforestation and or some illegality in the supply chain. So that's really where we may want to focus our efforts and look at maybe substituting plywood products for other more local, more sustainable products. Maybe locally sourced OSB or something along those lines is an option. It may be an option. So central point of expertise, this leads us nicely to what should we be asking for? Well, the UK government done a project on this back in 2004 after a number of high profile incidents on the government estate. And they came up with two forms of evidence to prove whether your timber was legal and sustainable. They first wrote what they meant by legal and sustainable, and then looked at that against a number of standards. And the two main evidence standards are PEFC certification and FSC certification, Forest Stewardship Council, the two main independent forest certification schemes. Other than that, you can look for timber from a UK forestry standard source, and actually Grown in Britain certification is starting to come through now. That confirms that your timber is from a UK forestry standard source, and things like FLEGT. FLEGT is a bit of an issue because it's difficult to track that to the site of use. Only the other three, PFC, FSC and Grown in Britain, have a chain of custody scheme, and we'll talk about chain of custody later, that tracks the timber all the way from the forest all the way to the site of use. So FLEGT doesn't do that, and that is a little bit of an issue with that scheme at the moment. So we're going to concentrate on the three main ones there, PEFC and how they differ. They all basically want the same thing. They're all looking for forests to be grown in a responsible way and make sure that not just that trees are replanted in the ground, but also that the people that look after those forests are looked after themselves. PFC is seen as more of an umbrella scheme. You've got a number of schemes sits underneath that. National Forest Certification Standards, such as the CSA's Canada, Responsible Wood in Australia, MTCC in Malaysia, SFI North America, and UCWAS in the UK Woodland Assurance Standard. And these are the woodland assurance standards that the forests are certified to in these particular countries, and PFC does certify in certain countries in Europe. And there's a two-way conversation there, and how they work, and the standards that they involve, but they all must meet that the PEFC benchmarks. FSC works slightly different. It's very much more of a top-down standard. It's got the FSC standard, that's translated into a national standard. Just so you know, UCWAS is actually the national standard for the UK. So any forest in the UK that's certified to UCWAS, the timber that comes out of that forest can carry PFC and FSC and actually Grown in Britain certification. Grown in Britain works slightly different. It's very much aimed at smaller woodlands, where PFC and FSC are seen as too expensive. So there's the Grown in Britain came along and developed a standard around the UK forestry standard. The UK forestry standard is the minimum standard for the UK, and that involves having a management plan for the forest and felling licenses for the trees. So it's still very much a sustainable standard. And then the Grown in Britain basically transfers and tracks that timber through the market in the UK. Just to give you an idea of where these certification schemes are more dominant, you can see there that PFC is actually the more dominant scheme in Europe. So where we looked at that map before, the UK and Europe was where most of our timber comes from. PFC is actually the dominant scheme. Only the UK and Sweden generally have a dual certification in effect of the trees. Dual certification in the UK. Actually in Sweden they certify each scheme separately, so it's not like the UCWAS scheme. But that's the only two places where you can get dual certified timber from in a lot of cases, or from two different schemes. America, North America, Far East, a lot of PFC as well. It's more the higher risk nations that we mentioned earlier on from the deforestation point of view, where FSC tends to dominate. Now that's not to say that there isn't any FSC forest in, say, Canada. There's more FSC forest in Canada than I think anywhere else in the world. So it's just a mix. It's just showing here what the dominant scheme is in those countries. Now the drivers, you're going to know a lot of these drivers, but probably the main one that started it was the UK government's timber procurement policy, which requires all timber to be from a sustainable source, and they will ask for evidence for that on projects that are from the government estate. That's been picked up by a number of building certification schemes, so things like BREEAM, LEED and SCAR all require certified timber for their schemes. And in addition to that, the UK timber timber products placed on the market regulations, which came out in 2013, and this is based on the EU timber regulations, now just applies to the UK because of Brexit, does keep an eye on that and requires, and this is just for legality, but he's a major driver in making sure that all the timber has got due diligence associated with it, and a lot of that due diligence can be covered by the certification schemes. But also UN Sustainable Development Goals, and on this one we talk about life on land, number 15 there as being a major driver. But actually, when you look at the, particularly FSC and PEFC standards, they very much pick up on every one of these points within the UN Sustainable Development Goals, particularly things like good health and well-being, decent work and economic growth, making sure good wages are paid, make sure healthcare is there, make sure there's good and clean water, but also things, and obviously climate action as well is a key one going forward. And we had a great discussion last night on climate for those here, and another one tomorrow, so I won't go too much on that. All I will do is point in the direction of things like the Wood Cost Less campaign, which is trying to promote timber there. But key driver, in my experience, has been the reputational damage. We've got all those key drivers there, but to make sure you get it right, people don't want to be seen in the press as getting it wrong. And this happened to the government. You can see there, this is the Home Office in 2003, DEFRA in 2005, Admiral Arts in 2006, and the one on the bottom right was actually one of my company's projects, Kelvin Grove Art Gallery in 2003. All of these, all these projects were accused of using illegally sourced timber. So it's trying to make sure that doesn't happen going forward is a key driver. So what should we be doing? How should we specify the timber that we bring onto our construction sites? Well, for me, there are 5 main points that we need to make sure that we cover in a specification clause. We must reference timber and other wood-based products. Lots of other wood-based products used on construction sites, make sure we reference those. Make sure you define the scope. It's not just the permanent works, make sure you include that temporary works as well. So, concrete formwork, hoardings, temporary protection materials, etc., all need to be within scope of that specification. As far as what is legal and sustainable, reference to the UK government central point of expertise on timber. It's a great reference. It saves you having to define yourself what legal and sustainable is. That document already does it for you. Key one for me, make sure there's a requirement for chain of custody to the site of use. Like I say, we'll talk about chain of custody in a minute, but make sure that's there. That's your guarantee when you get that delivery ticket on site that the timber that's arrived on your site is from a certified source. And where you can, put examples of schemes that meet that criteria. Now we've got a standard one here. I think Tabitha's going to be sending around slides possibly later on, but you can pick this out. This specification here, all timber and wood-based products for either temporary or permanent inclusion in the works must be from legal and sustainable sources as defined by the UK Government Central Point of Expertise on timber and be delivered to site with a full chain of custody. Chain of custody certification schemes recognised meeting the above include PEFC, FSC and Grown in Britain. So that's all you need to have in your specifications. That will cover all the timber on your project. If you're using things like MBS, we've been working with MBS and you can use their standards as well. So 105 timber procurement gives you almost the same requirements there, sets the chain of custody schemes that you need to adhere to if you're using MBS. So chain of custody, we mentioned it a few times. What does this mean? Well, chain of custody, we've got our forest and that's certified to, for example, Aquas. So the timber coming out of that forest can carry a claim, what we call a claim of either PFC, FSC or Grown in Britain. Nowadays actually it can cover all three. All 3 claims can be on the delivery ticket. Can't be on a label, but it can be on the delivery ticket. That material is delivered to a sawmill and that sawmill has to be audited against those chain of custody standards for those 3 schemes, again, to be able to pass that claim on to the next person in the chain. Talked about auditing earlier on, and NETTA talked about how their members are audited to make sure that they can pass those claims on. Again, that sawmill will pass that timber on to, say, a merchant. There could be an Arnold Labour, Travis Perkins, someone like that. Again, that organisation will be audited, and those branches will be audited to make sure that they are applying the standards correctly. And then that timber is delivered to site. Your site does not need to be certified. All you're doing is checking to make sure that the timber delivered to that site carries a claim on the delivery ticket. There is an option to certify the site as a project certification, but that wouldn't necessarily be talked about, and we were not talking about project certification at the moment. Any timber that goes anywhere else to be fabricated into a product, so if you've got furniture coming into site or windows or something like that, and that timber's either going direct to the sawmill or from a merchant before going to your site, again, that person doing anything to that timber needs to be registered with a chain of custody as well. And if you've got an inclusive policy that includes all the certification schemes, it doesn't really matter what certification one of those bodies holds. If they only buy, for example, our furniture manufacturer only buys PEFC timber, then there's no, there's no point in them having the other two certification schemes. So they might just hold PEFC and supply PEFC certified timber into your site. The issue comes is when they don't hold anything. They may be buying certified timber, but if they don't hold that certification themselves, chain of custody certification, they then can't pass that claim on to your site. And that's what we call a broken chain of custody. And in this situation, it's easy to spot because they wouldn't hold a chain of custody certificate. The trouble is where they are buying timber that's not certified from someone else down the chain. And that's where it's not as easy to spot, because you might go to your merchant or your timber supplier and ask for their certificate, say they're registered as a chain of custody, but you need to this is why you need to make sure that it's actually on the delivery ticket as well. So the chain of custody certificate, that's what one looks like. This is standard one. This is BM TRADA one. And this is for Arnold Labour, and it will show their, obviously their name and their office address, the scope of products that they sell, their certificate number, and things like expiry dates and project dates and start and expiry dates. It will also, if they've got a number of depots, obviously a timber merchant will have a number of depots, it will also list all of the depots that are certified under that scheme as well. Now you can see that on the certificate, and that information is also on the various websites for each scheme as well, and you can search for your supplier and see all that information. Good thing about the website check as well is you can see whether the certification is still valid. You might not be able to see it on your screen, but under status it says whether it's valid or not. Now obviously our timber turns up onto site and it's got its labels on to say that it's PEFC timber over here and some grown in Britain here and some FSC sterling board here. But what happens when that timber turns on site, it all gets, the packs get broken down and the timber gets sent off to different directions on the site, and you don't see that anymore. So the key bit of information I keep stressing is that delivery ticket. This is your proof that the timber is from a sustainable source. And you can see on here again, you'll have your supplier details. Make sure that the delivery address is your construction site. Make sure the delivery date is within the validity period of the certificates. Make sure it's got a correct claim. Well, we'll touch on that in a second, but make sure it's got a valid claim to say it's FSC, PEFC or grown in Britain. And obviously make sure the certificate number's on there and there's a quantity as well. There are some various tools to help you check this. PEFC's card is great, so if you need any of these, I'm sure PEFC will be willing to supply these to you. But there's a great little check card there you can hand out to staff on site to make sure that the timbers, make sure it's easier to check that the timber's from the same right source. So we talked about claims. Just a quick touch on what claims you need to look for. Chain of custody claims, if it's all from a PEFC certified forest, for example, you will see on that delivery ticket that it says 100% PEFC origin. But in a lot of cases, you will see a percentage claim, and the minimum will be 70% because that's the minimum recognised by CPET. But that doesn't mean that only 70% of that timber is sustainable. All of that timber is sustainable. What it's saying is only 70% is from a PEFC certified forest. So in this example, we might have 70% from an Aquas forest in the UK, which carries PEFC certification, with 30% coming from a UK forestry standard source, which doesn't meet the requirements of PEFC. But that would go into the sawmill, they would mix that in the sawmill, and it would come out with that 70% claim. So all of the timber is from a sustainable source, but only 70% from a PEFC source. That's, raw timber, say sawn timber product, but it may be a product like a door. And in that case, the door manufacturer further down the line here may be buying timber from two different sources. One is maybe the FSC chipboard core, and the other bit is a PEFC certified, say, oak, veneer and lippings. And in that situation, that particular door manufacturer can decide which one he wants to go with. By volume, obviously. So in this case, it would be FSC. He would do his what he call controlled risk assessment on the PEFC timber coming into that door, and he could then give that a claim, an FSC mixed 70% claim. So again, all of the timber going into that project is lit from a legal and sustainable source, but only 70% of that is FSC. Okay, so just to finish off, a little call to action here from us from myself, really. Hopefully you got a little bit more of an understanding of responsible timber. I know it's been a little bit of a whistle-stop tour there because of time tonight, but again, if you want to listen to the full presentation, look at the PEFC website, and we can you can join one of those open sessions. But what we should be saying is ensure responsible timber procurement is on your sustainability agenda for this project. Make sure that it's thought about when you're looking at your schemes that you're designing for Sunderland, Riverside. Consider what timber you specify and where this may be sourced from. So think about what we talked about plywoods, and maybe looking to see if you can get something closer to home, whether that's maybe a PEFC certified softwood plywood rather than a hardwood plywood from somewhere like from say a Worcester spruce or something along those lines, or whether do you need to use plywood? Could you use an OSB board, for example, instead of a hardwood plywood? Ensure that all the timber you specify, you specify timber certification schemes that meet the CPEC requirements. So like we said, they are at the moment PEFC, FSC, and grown in Britain. And ensure, when you do start a project, if you are looking after it, ensure the timber that is delivered to the project with full chain of custody. So thanks for your time now. I won't worry about the feedback, but I'll just leave some contact details on there for a second and hand back over to Tabitha. But that's Alan's details if you need them, and my details on there as well. Thank you very much.
Thank you very much,
Tabitha.
Charlie.
And I'll just start sharing my screen now so you can hand back.
That is brilliant. Thank you for the whistle-stop tour. And absolutely perfect. Iain, can I introduce Iain? And Iain, if you'd like to start sharing screen. Iain Thew is a structural engineer by training, and he is going to talk more about structural timber, both solid and engineered. The floor is yours, Iain. Your screen sharing, but we can't, you must be on mute.
Thank you, Tabitha.
That's it. Perfect.
Yes, so my name is Iain Thew, and I'm a structural engineer at Structural and Civil Consultants Ltd in Northallerton. And I'm going to be giving you another whistle-stop introduction to timber as a structural material.
If you go right down to the bottom left-hand corner of your screen and just over it. Perfect.
So, timber as a structural material. What makes wood an attractive material for construction? So first of all, it's widely available, and if it's coming from sustainably managed forests, like Charlie's mentioned earlier, then there's an increasing source of that. So it's it's widely available. It takes little energy to produce. So Tabitha's already mentioned that a lot the work is already done by the tree. So it grows in the forest, takes the nutrients from the soil and the energy from the sun, and all we have to do is go and harvest the trees, cut them up into usable size shapes, and it's ready to use. It's a very strong material. It's got good strength to weight ratio, performs well in tension, compression and bending, and it's easy to handle and work with on site. And as long as you keep it dry, it's also very durable and can last an awful long time. So just in case you don't believe me, here's an example of a timber structure that's that's around 900 years old. It's a stave church in Norway, built in this log form of construction, and some of these log posts have been dated using dendrochronology to having been felled in 1034. So you can see that they've been felled nearly 1,000 years ago, and yet we've still got a perfectly usable perfectly usable structure. So it's a natural material, And it's important to remember that wood isn't really just one thing. There's thousands of different species, as Tabitha's mentioned, and also different environmental growing conditions have an effect on the properties of the timbers. So a Sitka spruce grown in the UK will have different properties to Sitka spruce grown in its native Alaska, for example. So we need to think of a way that we can sort of categorize this timber so that we're not using timber in an inappropriate place in a building or structure. So this is quite a detailed diagram of the cilious structure of timber, but really I just want you to concentrate on these long cells that Tabitha's already mentioned. These fibres run up along the axis of the trunk of the timber, and the direction of these fibres is what we call the grain of the timber. These are what give the timber its characteristic strength along the grain. Like Tabitha's example, a big bunch of straws. It's important to note that the bonding between the straws is not very strong, particularly in a tensile force. So although it's strong along the grain, across the grain, timber is not so strong. So here's a couple of the most important natural characteristics within a piece of wood that affects the strength. Once we've taken our log and cut it into usable square sections, these are the two main natural defects we'll be looking at. So we've got knots on the left-hand side here, and these knots cause grain distortion. So where the grain distorts around the knot, the grain is no longer straight, which causes a weakness. And there's also a discontinuity because the knot effectively comes through the straight fibres. On the right, the slope of grain, we said how the timber is strong along the grain, but once you start once the grain starts to be angled to the axis of the piece of timber, then it weakens. And you can see here how this piece of timber has just sheared through because of the angle of grain, which you can see is about 30% to the piece. So looking at these natural defects, we grade the piece of timber. So there's two ways we can strength grade timber. We can do it visually, i.e. a human being looking at a piece of timber and using rules based on the sizes of the knots and the angle of the grain to decide if a piece is strong enough or is not strong enough and is rejected. Similarly, you can use a machine to use a non-destructive test, such as sort of bending it or scanning it with a laser to pick up these natural defects, and again categorize as a pass or a fail. And the strength grade in combination with the species and the origin of the wood allows us to assign a strength class to that piece of wood. So strength classes are defined by a letter followed by a number. The letter stands for softwood or hardwood, C or D class, and the number represents the major axis bending strength of the strength class. So that's in newtons per millimeter squared. So a C16 piece of timber would be a piece of softwood that has a bending strength of 60 newtons per millimeter squared. So here we've just got a table of some kind of common lengths and sizes that you'd find. This from BSW, so this is all generally UK grown timber. It's got the species. It's also important to note that the finished size isn't actually the same as the sort of nominal size that you think you're specifying. So if you were, it's important if you're doing designs to always use the finished size, as this is smaller. In this case, it's a planed piece of wood, so it's lost some of its section. So if we take our floor joist in service, this is a sort of idealized diagram of what's going on. It's spanning, let's say, between two walls, and the joist starts to act in bending. And this applies stresses through the beam. But the stresses aren't equally distributed. There's compression on the top of the beam and tension on the bottom, with the maximum stresses at the top and bottom faces. And in fact, there's zero stress along the neutral axis on the center of the beam. So if we think about that, that means that actually a lot of the timber in the center of a standard section of timber is not really being used efficiently because it's got very low stresses. So there are natural limitations to solid section pieces of timber. Also, just growing sections of timber for larger spans takes more time, which is more costly, and obviously modern harvesting, growing and harvesting techniques, you're looking at a 50-year rotation. So actually growing really large sections of timber just isn't very easy. Also, there are just limitations on how far an actual piece of timber can span. You can see this this photograph of a late medieval roof, and you can see how complex it is in order to span from one wall to another. So that's an awful lot of complexity and cost. Although it is obviously a very beautiful structure, not all clients want to pay that amount of money for a structure like that. So if we're wanting to make timber span further, then we need to think about how we're going to come up with different ways of using it. So one method of using timber more efficiently is in engineered timber eye joists. You can see on the photograph that the majority of the material is concentrated at the top and the bottom. This is where the maximum stresses occurred, if you can remember. So this is using material a lot more efficiently, and then we've got just a thin web where the stresses are lower. So this produces a much stiffer, lighter structural member, and it's also easier to source high quality defect-free sections in smaller sizes. So for timber eye joists, we can have solid web eye joists, like this example here, which has got an OSB web, but they can come in other board materials, including plywood or any structural board material. And again, the flanges are often solid timber, but in this case, I think they're actually LVL, which is another engineered product made up of layers of timber glued together. And you can also get metal webbed eye joists. So these have advantages in terms of installing surfaces. It's very easy to slot them into the depth of the floor, and these are also easier for sort of smaller scale manufacturers to construct. So there is sort of more producers around. And yeah, these eye joists give you that advantage of being able to span further with less material. Another engineered material that has been developed is glulam. So throughout the 20th and 21st century, there's been this tendency towards larger structures, larger spans, and in just solid natural timber, there'd be a risk of kind of timber being left behind. So in order to sidestep this, and with the sort of increasing development of really good structural adhesives, it's allowed the development of glulam, or glued laminated timber, where small sections of timber, sort of high quality defect or low defect timber, are glued together. You'll notice that the grain of each of these small sections is running in the same direction, so that the strength along the grain is maintained, and these are typically used in beams. So here's just an example of just how large you can construct them, and that's sort of 1.2, 1.5 meters deep, and yeah, they can span sort of up to 30 meters. And really, the major limitation is actually just getting the beam onto site on the back of a truck. Just another photograph. That glulam is also very popular architecturally, just because it's visually very appealing, as well as being a very high-end structural product. So we can form glulam in two different ways, with the stresses being concentrated through the section at the top and bottom. We can take advantage of this and put higher quality, higher strength class material at the top and bottom of the laminate glued section. So that's called combined glulam. And alternatively, if all the sections have the same strength class, then that's known as homogeneous glulam. And the final engineered products that we're just going to look at is cross-laminated timber. So again, it's manufactured in a very similar way to glulam, but rather than the sections all being glued in with the grain or into the same direction, these are formed cross-banded. So you can see that the grain on one layer is perpendicular to the sections above. Yes, so this is used to form, rather than beams, this is used to form large panels, which can be used to construct walls and floors. So just some of the advantages of CLT. You can these large panels can come to site, and they can literally just sort of be stacked on top of each other. So you get increased speed of erection. The very sort of large volume of timber used in CLT allows it to be used in much taller buildings, and it also produces a higher standard of airtightness, because you've just got these big panels stacked on top of each other with tight joints. So yeah, this is just a 7-story student accommodation block that I inspected. There's nothing on the outside to particularly say that it's obviously CLT, but inside one of the lift shafts, you can see quite clearly that you've got the CLT walls here, with a floor panel stacked on top of that, and then another wall going up. It's also worth noting that you've always got an odd number of sections because the top and bottom sections, the grain needs to run in the same direction for CLT. So I started with a very old Norwegian building, and I'm just going to finish with a very new Norwegian timber building. So this is the Mjøsa Tower in Norway, completed in March 2019, and it's the tallest timber structure in the world at 85.4 meters tall. Yeah. Right.
Thank you very much, Iain. So if you've got any questions for Iain, you can save them to end or possibly ask them in the chat box. I'd now like to hand over to Professor Robert Hairstans from Edinburgh Napier University, who's going to lead us through offsite manufacture.
Hi, Tabitha. Can you see my screen now? Is that okay?
Yeah, screen's good and you're on.
Yeah, okay, good. Thanks very much for inviting me along this evening, and hi to everyone. So yeah, I'm Professor Robert Hairstans of Edinburgh Napier University. I run a research centre there on off-site construction and innovative structures, and this evening I'll introduce you to off-site and indeed industrialised forms of timber construction. So yeah, that's yeah, just a wee overview of what we do. We undertake applied research, building upon basic research in order to create impact into the sector, in order to create the sustainable communities of tomorrow. We do that through external engagement, working with stakeholders such as TRADA and others on this evening's forum. And we underpin that through student talent, through our Built Environment Exchange programme, where we actively engage students in our core research and activities, etc. So just to mention some of our sort of core research areas at the moment, we have thematic work going on in off-site productivity, capacity, human capital in terms of skills and affecting cultural change in the sector. A lot of work in mass timber construction with a large focus on integrating the supply chain or the value chain, so we get more homegrown timber utilised in these products and systems, and there's a lot of good stuff happening in that regard at the moment, and a lot of work also in digitisation. You know, the premise for that really is to demonstrate the whole life value proposition of why you should use timber and offsite industrialized forms of construction. So yeah, we do a lot of this stuff and generate a lot of outputs. We work closely with Construction Scotland Innovation Centre. We have an established relationship with Trimble in terms of digitisation. We work with homegrown products. We also work with imported products and systems, such as even the sort of Multiply project at the bottom sort of right-hand corner of the screen there. And we exhibit this work publicly to try and affect change. You know, so it's not just about you know, stakeholders and government ministers, etc. It's also about, you know, the public and ideally them understanding the benefits of offsite and industrialised forms of construction. But I think this evening really it was to look at one of these outputs and give an overview of this, and really just work through sort of a bit of a synopsis of this book that was produced by myself on behalf of TRADA. So we'll use that as a sort of framework for what we'll go through and how these types of approaches really can look at delivering quality and efficiency. So yeah, offsite is really interesting. You know, just a bit of background context. It's not actually that new. You know, we can even go back to the likes of cruck frames, but it really took hold early 19th century. You have things like the Manning cottage, which were exported, you know, as a result of sort of colonisation in Australia, etc. So lack of skills, need for shelter. So you know, houses essentially fabricated in the UK and shipped abroad. So these forms of construction have evolved. So I mentioned cruck frame, you know, manufactured off-site in carpenters' yards, then for quality assurance purposes, and then, you know, before they're shipped to site as such. But post and truss forms evolved, and post and beam, and then you've got modern post and beam systems. And I think what's interesting is these forms all still exist, even cruck frames, you know, Oakwrights, for example, in the southwest of England, but they use CNC machining for their joints. We have, you know, other forms of timber frame, so the sort of box frame construction, balloon framing in America, which became evolved to platform framing, and then you have the modern sort of closed panel systems, so more levels of enhancement, incorporating engineered products and systems within them. And again, these forms all still exist in a sense. And even the sort of mass timber products, you know, again, an evolution of what's taken place. You know, we had sort of round log construction with, you know, sawn logs to create, you know, square log construction, and then with the advent of mechanical or indeed adhesive types of fixings, we had, you know, the creation of cross-laminated timber. So it's, as I say, these forms of construction have evolved and have evolved as a result of the material and the context, but also the type of, you know, the timber in the region, etc. But we can loosely sort of categorise offsite into sort of 4 broad categories of panelised, volumetric, hybrids, where you've got sort of combinations of these, or indeed sub-assemblies and components. And you can either have one consistent form as such through your building, or a combination in a sense. So that's where you move towards levels of say, customisation. So, you know, as I've explained, things have evolved, and, you know, mechanization has evolved, and now we've got, you know, even full production lines with higher levels of mechanization, or indeed automation of, you know, even things like robotics coming more to the fore. And all of this is about improved levels of sort of quality and efficiency, and it's balancing that with the relative level of standardization and indeed the product supply chain. So, and I mentioned digitization, use of computer-aided design and correspondingly computer-aided manufacture, and in line with that, thinking about how you design for manufacturing assembly. And I like to think of what are the capabilities of your manufacturing setup rather than the restrictions. So what are the capabilities of it, and correspondingly how do you design for manufacturing assembly? And perhaps if you want to think broader than that or beyond that, what does this mean in terms of circularity and correspondingly disassembly, reuse and reutilization, or that you maximize the value of the resource in the built environment? So when you're thinking of offsite, thinking of it in terms of a production flow, thinking of your standard production flow, or what you could be doing offline from that standard production flow, in order that you create degrees of you know, standard product and customizable product in order to reach the client's requirements. And of course, how you do this in an efficient manner, and how you adopt the principles of lean. So, you know, teamwork, just in time, communication, transparency, waste reduction, not just product waste, but also, you know, time waste, etc. So it's all about how you, you know, embrace these types of theories and approaches. In line with that, you know, there's modern methods of construction is often a terminology used. I think key for me on when you're thinking of MMC, it's about efficiency and effective ways of working, and innovative ways of doing things. So there are sort of categorizations of it, but I tend to think of it more broadly than these categories, because one of those categories is other. So those other forms can actually take place on site. Such as full floors built at ground level and then lifted into position, or the proprietary construction of a roofing system. So there's other forms, you know, of what you can do, not necessarily sort of fully off-site. In line with that, you know, there's the sort of farmer review and thinking about pre-manufacture value add, in terms of what you're doing, what level you're doing off-site, and what sort of proportion of modern methods of construction you're applying on site, in terms of gaining your efficiencies and your meeting your clients' needs, and in terms of customized solutions, etc. So, you know, without getting too bogged down in terminologies, you know, it's just to point out that there are a range of products and systems available, you know, panelized, hybrid forms, large section framing, volumetric, mass timber construction. And we'll touch upon this as well in terms of mobile, digital fabrication, pop-up factories, the flying factory. So there's a whole myriad and ways of doing things, but it's about how you deliver with efficiency, and thinking of design for manufacturing assembly, and indeed disassembly, reuse, and then, you know, to that end, circularity. and correspondingly a more industrialized approach, employing lean techniques. And when we think of panelized systems and thinking of combination of materials, just to touch on things like even structural engineered panels, you know, I tend to prefer more natural forms of construction, but you know, SIPs oriented strand board with expanded polystyrene manufactured, you know, off-site to you know, to improve thermal performance, air tightness, and reduce things like cold bridging. And these types of products and systems, you know, have advantages in terms of how they combine materials for improved structural performance, and as I say, reduce things like cold bridging, and indeed they can be quite adaptable forms of construction in terms of how you can make these panels and then, you know, cut them up to form different shapes. And they're, you know, a kind of neat example of where it's been used in an observatory, because seemingly telescopes, high-powered telescopes, need to have good moderation of internal thermal performance. So I think it's given due consideration to the context to which you're applying the techniques. So solid laminate timber systems have been touched upon. There's a full range in there. There's glulam, there's laminated veneer lumber, there's cross-laminated timber, which use adhesive bonding techniques. There's also the structural composite lumbers like laminated strand lumber or parallel strand lumber. You know, they tend to be more in North America, but we have a lot of LVL, certainly via Metsä wood in Finland. But you have mechanical forms as well, nail laminated timber using aluminium nails, so you can CNC machine. You have dowel laminated timber, which uses hardwood dowels of low moisture content, which swell and lock together the softwood lamellas. So they have a mechanical performance through full utilization of timber and different timber types to make that mass timber component. As has been touched upon, there is, as a result of these mass timber products, you know, exponential growth as such within the market, and it's grown from these stats in 2017, and you can see that there's still, you know, a huge volume of timber that can be utilised for these types of products in order to sequestrate timber in the built, sequestrate carbon rather in the built environment, and these mass timber products and systems and engineered products and systems provide scope for, as has been touched upon, larger spans, or you know, higher stories and so on. In terms of that, again, cross-laminated timber manufactured off-site, defect cutting, removing the knots and finger jointing, you know, stacking the lamellas up, and then, you know, obviously applying an adhesive and pressing that. And then at the end of it, CNC machining. So again, what's key in that is, because you're using adhesives, it has to be a controlled environment. So managing moisture control, etc., and having high levels of quality, performance, and accuracy. So, you know, that the research work for CLT, you know, has been claimed to start in the sort of 80s. And currently we don't have a manufacturer in the UK as such, a commercial manufacturer. We do produce it in Scotland on a pilot scale through the Construction Scotland Innovation Centre, and indeed we've just finished a project there before Christmas to be exhibited at COP26. But the main stuff is really imported. You know, there was the original sort of projects in terms of Stadhouse, and then there was, you know, a lot of work by Watkins architects, you know, and others really pushing the boundaries in terms of how this product can be used. Of course, things that are impinging upon that just now are, you know, fire performance, the Grenfell Tower disaster, etc., and restrictions in terms of story heights. Nothing to do with timber, but ultimately its impact upon, yeah, how timber can be utilised in the UK market. Yeah, as I've mentioned, not just CLT, large section framing, CNC machining, using things like Hundegger machines, a lot of work in Germany in these types of systems, a combination of post and beam techniques, and panelized systems, and you've probably seen these sort of high spec hoof houses and maybe the likes of Grand Designs. You know, what's interesting here is the standardized building components and systems. You've got companies such as Lucas Lang that have a platform approach, standard connections, or and a sort of gamification of how you can put this together to produce built systems. So standardized component parts which you can sort of customize relative to their levels of flexibility. In line with that, volumetric, where you move to a high level of enhancement in the factory environment. So you do really have to think about the levels of standardization and repetition through that production line. You also have to think about your transport, your logistics, and with the additional weight of a volumetric system, where do you place a crane on site, and can you lift that volumetric unit into place? So a lot has to be thought about through that in those design stages as you move up to higher levels of enhancement. And often that's why hybrid forms are very useful, because you can get that combination of the different forms of construction. And there's really good big showcase examples of this in the UK. So timber-based forms of it aren't just used for housing; they're used for things like the B Sky B showcase building, and that was a hybrid form in terms of engineered timber products and cassetted forms with a large glass facade. And hitting things like BREEAM excellence. And we have, of course, being in Scotland, being Scottish, we've got to bring up whiskey. We've got the Macallan distillery, visitor experience. You wouldn't necessarily think this is an offsite or has offsite forms of timber construction within it, but it is a hybrid form. And the roof structure indeed was formed using engineered timber systems and cassetted roofs, which were fabricated as such and dropped into position. And what hybrid's also doing is helping to push the boundaries of where timber is being used. So we have examples of where these mass timber products are being combined with steel and concrete as well. And to that end, there's interesting things in terms of timber concrete composites also. But yeah, these hybrid systems are helping to push some of the boundaries, and as also had been mentioned, it doesn't necessarily have to go to combination with other materials, because we have such as the Mercernet project in Norway, the tallest timber building, which is principally engineered and mass timber products that have been utilised for the delivery of that, and a lot of work undertaken to ensure the right fire performance measures were taken. So a lot of good information that's out there and available. And then just to touch on it, going across this, I mentioned, from the hybrid, the tall timber buildings, but then we have things like the mobile and the flying factory for the much smaller scale. So in the US, there's even mobile framing equipment which you can take to site, to get levels of accuracy and consistency in what you're manufacturing there. You have mobile sawmilling equipment, for that you can take to the resource. You can air dry the resource. It takes a wee while, right enough, and then you can you can obviously use these sort of sawmill equipments and move them around different parts of the to more rural locations. And sort of work that's been pioneered in this regard, sort of Mod Cell and their flying factory concept. So you're using pop-up factories in agricultural buildings to fabricate large section frame and using natural forms of infill and insulation, often sort of straw, etc., to create a high thermally performing product. So that's sort of alternative scales, but it gives it hopefully an idea of the range and types of techniques that can be utilized. And in that regard, there's the likes of WikiHouse, an open platform where you can download as such CAD CAM files and put that into a CNC router and manufacture plywood into the appropriate shapes and fix it together. And there's underlying theories of that were developed at sort of MIT by Lauren Sass, etc., that you could look into in terms of how these types of approaches can even be used for disaster relief, so you can fabricate close to site, and you can do it. I think the important thing about that there again is the efficiency and effectiveness of what you're doing, because of the CAD/CAM approach, you can ensure the minimisation in terms of the minimisation of waste. So WikiHouse is an example of that, and there's others such as was shown in the I think in the previous slide there, Facet Homes, who you have this sort of pop-up container that's shipped to site in order to CNC plywood and fit it together. So some really neat examples. So I hope that provide you with sort of perhaps an enthusiastic walkthrough of offsite and industrialised forms of construction. And just to finalise off on that, this is something that a colleague, Mila, who will talk to you all after myself, worked on, was really about offsite construction or construction, the drivers within the construction sector at the moment, and those drivers have become more complex over time since, you know, the cruck frames, the manning cottages, etc., to where we are now in terms of digitisation and more higher levels of regulatory conformity to reach the sustainability requirements and meet those sustainability goals that Charlie touched upon, how we affect change in construction culture, move from away from our adversarial approaches, how we have improved business models, how we think of whole life value proposition, not just lowest cost, lowest quality form of delivery, how we infuse that human capital, how we look at leadership and collaboration and upskilling, and fundamentally how we improve the levels of productivity. And when we do that and we think of the improved levels of productivity, we have to think of the output or the input as well as the output. And if we're using carbon intensive materials as part of that input and we increase that output, then we'll only accelerate the tipping point to climate change. So if you think about all those drivers, you think of the convergence of those drivers within the context which you're looking at, hopefully you'll be able to select the right form of offsite construction and the right type of industrialised timber approach. So with that, I'll thank you very much for your attention. Thank you.
Thank you, Robert. That was absolutely brilliant. And so, as Robert mentioned, he has written an offsite book, and I've put that in the chat box. So there's a link direct to that. And can I now introduce you to Mila Duncheva from Edinburgh Napier University, who's going to take us through some fabulous resources that she was highly involved in developing, offsite ready.
Thank you so much. It's a real pleasure to be here with everybody today. Now, just before I share my screen, I'll just give you a couple of sentences about who I am. So I've had the pleasure of working at Robert's Centre for Offsite Construction and Innovative Structures for about 4 years now. I'm now a lecturer in architectural technology, delivering teaching as well as research in architectural technology, construction management, productivity, skills, all that good stuff that we need to drive the built environment towards a more sustainable future. Yes, that's exactly what we need. And so I'll do the usual share screen. And so, yep. So just to check.
Yeah, all good.
Yeah, you can see that. Okay, fantastic. Yeah, so I'll introduce to you Offsite Ready, which is one of the more recent projects we have completed. And then I'll point you to some useful resources that you can use while you're developing your designs for this competition. Now, there's a lot of background to this project, and it has to do with work that has been ongoing over the years, which is all about, as Robert introduced, building systems have advanced as we have progressed with all these new engineered systems that we heard about earlier as well. But what about education? Is education, catching up with these new methods of building? The answer to that, as was identified in the 2019 report by CITB, faster, smarter, more efficient, building skills for offsite construction. The main conclusion was that no, education has not caught up to these new systems, and hence why you're participating in this very innovative challenge as well. And that report recommended that standalone courses and training materials need to be created to really bring the education sector closer to what is happening in industry. And that's why CITP invested £1.2 million in 2 projects, one led by the Construction Scotland Innovation Centre, which I'm going to talk about, and the other one led by the Manufacturing Technology Centre. So our project was led by CSIC, and we at Edinburgh Napier University were responsible for managing and creating the learning content, as well as working with a whole range of partners, which was a really fantastic experience. So City of Glasgow College ensured that the content was leveled to the appropriate accreditation standards, as well as developed our Train the Trainer program, which has been very, very successful. As well as MOBI, the Ministry of Building Innovation and Education, of course, brought in a lot of expertise and design challenges, as well as lots of outreach in England. Class of Your Own did a lot of outreach of these materials among school level, which is very important in order to attract more young people into the built environment. And the Construction Wales Innovation Centre delivered a lot of training events targeted at a Welsh audience, as well as contributed to some of the procurement aspects within the learning materials. The aim of the project is really to increase the knowledge and skills and capabilities of trainers and practitioners in the industry, but it also provides a whole range of freely available content. And indeed, you do not need to be uneducated in order to access it. Indeed, we're finding out that more and more students are accessing this content on demand to help them with their design projects. A wide variety of audiences can use this content, and these are some of the key people who we targeted with the creation. Now, I'll just very briefly talk about the process, which underpins all the materials which you can see on the website, just to show that this is really evidence-based. This was a really rigorous approach which we followed over a long period of time in order to make sure that we were providing the most engaging but also accurate and current information about offsite construction. So we started off with a competency framework, which was developed by the Construction Scotland Innovation Centre, and I'll touch upon that in a minute. Okay. Afterwards, we consolidated our existing resources using a reference manager. And after that, we developed a standardized body of knowledge, which defined lots of our definitions and really demystified some of the use of terminology. And only after that did we start looking at the flexible modules, or the content that you see there, and the teaching support system, which is the guide pack as to how you can use those resources. Now, there was a lot of inputs and outputs within each stage. I will not bore you too much with that at this hour. But yeah, so this is just a sample of the competency framework, which you can see as a series of PDFs, and it is really underpinned by this report, which I mentioned earlier, which identified the key gaps across the whole life cycle of offsite constructed projects, ranging from digital design through on-site placement and assembly, alongside other key resources. And so the competency framework, I like to think of it as the 3 dimensions of space. So we have the backbone, which is the Z axis, and that really gives us the key functions or the actual knowledge that people need to have in order to undertake a successful offsite constructed project. We also have the knowledge categories, which is about how do you categorize that knowledge, and very importantly, underpinning all of this are also the softer skills or the business skills and transferable skills. And the material within all of that, we've got different roles, different targets, target learners, ranging from skilled workers for supervisors and managers, to ensure that we hit everybody across the board with the content they need for the different life cycle stages of offsite constructed projects. And so here you can see, for example, all the functions which start from offsite fundamentals through to digital design, estimating, commercial logistics, offsite manufacture, on-site placement and assembly, and finally site management and integration. So you can see how they follow the whole life cycle of the project. Now at this point, I want to show you the actual website. Just to check, do you see the Offsite TRADA website now? Could somebody let me know?
Yes, we can see it, Mila.
Okay, that's great, thank you. And so you can access it very easily just by going to offsiteready.com, and that'll take you to our landing page. Now here you can find out a little bit more about the project, and if you're interested, you can also enroll in our live Udemy course, which will also give you a certificate of completion at the end. But the main thing I want to show you is that if you click here on training materials, you then get to see all these learning materials that I was talking about, and they're all quite interactive. So first of all, you can see the competency framework, which is a PDF, and lists all those different knowledge categories, as well as soft skills according to the different roles that I was talking about. And then if you click on either one of these images, you'll be able to see all the learning materials in each module. So each of these is essentially a module, and each module covers a step in the offsite project lifecycle. Of course, offsite manufacture is one of the most critical steps in an offsite constructed project. And so I do want to show you just a sample of the materials available using this module as the base example. It has some sound, but it is not absolutely necessary. So the example you see here was a custom jig for volumetric construction, and now we see fantastic animation of a mass timber manufacturing process. That's great. And so you can see, the quality of materials that are available online, and just to give lots of credit to Lenka Cover, who created that animation. So for each of the modules, you can start off with a reanimation that shows you the main topics about the module. You can have a look into the more in-depth module descriptor, which, as I mentioned, is just a simple PDF. You download it, and that tells you what you learn according to each category. And these are all numbered. For example, 5A.15 is the module number. It's all about understanding current, new, and emerging technologies. And this is a description of what's included. And then if you go to something like the PowerPoint slides, and you see that starts with 5A, And then you have 5A.1, understand current new and emerging technologies. And that way, using those codes, it becomes very easy to find what you need, whether you prefer to learn using PowerPoint slides or whether you prefer to learn using PDFs, more technical PDFs with detailed explanations. You can very easily find the information you need, and it's all evidence-based, using lots of interviews with people who are working in the UK and offsite construction right now, using lots of fantastic images created by Carola Calgagno, and also lots of project case studies from the Offsite Ready Awards. So you can see the level of in-depth, the knowledge that goes into each of those sections. And if you do want a handy summary, there is also an infographic available for each of those modules that summarizes the key point within each step of the project life cycle. And if you do want to see more of me talking, as well as my colleague Katrina Jordan, there are also some talking head videos. So just so you can see there's a whole range of resources there, whether you want to listen to somebody who's written the materials talking and explaining about their work, such as Dr. John Stinson, or you want to see Katrina Jordan and me summarizing the contents from the modules in a video, or you prefer to read a more in-depth PDF. There's lots of information right there for you. And finally, if you are looking for some inspiration for your design challenge, you can also check out our teaching support system and then student design challenge page, which has some sample videos as well as vlogs that show the student journey along the way. So again, I'll just show one of these very briefly, not the whole, but you can see the beautiful timber structure there. And of course, many thanks to SWECO as well as West Lothian Council for helping us with this summer design challenge. And so I'm going to stop sharing now, and just thank you all for your time, and I hope that website is useful for you.
Thank you very much, Mila. Yeah, no, fantastic resource. I popped the Offsite Ready direct link into the chat, but if you would like to post any, direct links to some of the resources you've talked about, then absolutely fine. I wonder if all our speakers would unmute, because we have some questions coming in. And yes, if any of our student participants would like to ask some questions, then that would be great. First one we have in is for Iain. Where can we find design guidelines for timber I-beam joists? So far we have used EC5 for solid timber beams, but nothing on composite beams. Also, would you be able to guide us to any resources which can help give us a structural design framework for composite sections? Maybe Robert can also help out on this.
Thanks for the question, Hamid. Certainly for I-joists, in terms of the sort of information on performance, you really have to look at the manufacturers' websites, and they often have a sort of fairly simple kind of online design package. Sometimes it's fairly kind of simple, and you might actually have to contact them directly. They often actually do the design in-house. Equally, there's companies like MyTech who produce design packages for particularly the posi joists. Manufacturers like James Jones who do the I-joists, or I think Wolf joists, that's another one of the posi systems. So I would normally just Google various manufacturers, and often there'll be information on their website on that.
Yeah, I would just totally agree with Iain there. Principally through the manufacturers is where you get the information. So James Jones, NETTA would. There's a number of others that aren't springing to mind. I'm sure they'll be sending me emails that I haven't remembered them. But but yeah, if you look up the main manufacturers, that's where you get the spec. And as you say, a lot of them even have wee tools on their website which allow you to do the design. And with MyTech, it's the Posi joist, which is slightly different. But again, it's got, well, they've got their own software platform for the specification. And then similarly with the composite ones, you know, NETTA wood for laminated veneer lumber, and then there's the other ones in terms of parallel strand lumber and the other sort of structural lumber composites. It's via the manufacturers primarily where you'll get information. And I think the other areas are maybe the iStruct handbook, you know, the EC5 handbook. Certainly it should have some standard information in there in terms of specification, or you can refer to some of the Eurocode 5 textbooks even, and if you want to go back to sort of first principles for designing them as well.
Thank you, Robert. And I know we've got Nick Bolton was in the room. So Nick, I don't know if you want to say anything or post something in the chat.
Tabitha, I was going to answer some. There's a few questions that came in during my presentation I was going to pick up, if that's all right. If,
absolutely fine.
Unless Nick wants to come in beforehand, but if not, I'll pick up those. There was a couple of questions from Jim around CPET saying it no longer exists. He's right, the CPET doesn't exist, but the guidance is still valid. Although the funding was withdrawn in 2015, the guidance remains valid on the DEFRA website, and that includes the government TPP, the Timber Procurement Advice Note, which tells them how they should procure timber, and the definition of legal and sustainable. So, and I know that's been looked at. I think the Forestry Commission have picked up to look at it. But I think that's been delayed, obviously, due to COVID and everything else. So the guidance is still valid. The bit around now Office of Specification Standards, it's now the Office of Product Safety and Standards, which sits under BASE. That only covers the regulations, so that covers the enforcement of things like FLEGT and UKTR legislation. Just while we're on that, FLEGT, the other question was FLEGT approved by government as fully acceptable? Yes, it is. It doesn't sit in one of the categories. It sort of sits on its own FLEGT. That is fully acceptable. The big issue with FLEGT, as I mentioned in the presentation, is there isn't any visibility of that when it turns up on site. At the moment, there's no requirement for that to be on the delivery ticket, which does cause problems for sites, especially if they're going for a certification standard such as BREEAM or SCAR, which insist on FSC, PEFC, or in the main on those two. The other question that came through was from Cal Hewitt. Could you say that FSC is ultimately failing in its aim, looking at these nations which are considered high risk, all being not dominated by this scheme? Absolutely not, is the answer to that one. The issue with many of those high risk nations is that they don't have a robust national forestry standard. Hence, that's why FSC have gone in there, because they can go in and set up their own standard within a forest within that country. So that's why you see FSC dominating those areas. At the moment, the countries are adding their own standards to the list, and then in that situation, that's where PEFC can then also come in and adopt that national standard if it meets the PEFC requirements, and that's what happened. And as Alun's comment against it in the chat, there are good areas inside corrupt countries, so sometimes you have to look at the regions or the concessions. So you can't consider a country as a whole as being, we can't buy stuff from there. What you've got to look at is making sure that what you do buy is from the good bits, and we should support that, because that then if you make sure that you're buying stuff from FSC or PEFC or in the main for the international timber, if you're buying it from those areas and those without certification, that then promotes the use of those standards in those countries more, and we should get more certified timber. Thanks, Tabitha.
Thanks, Charlie. Nick, if you You disappeared off my screen now. Ah,
Actually, I'm still here. I'm still here. Yeah, I just posted a message on the chat. I mean, truss rafters and metal web joists, generally they're supplied as designed elements. So there's bespoke software that goes with the steel elements of those materials. So either the truss plates or the steel webs that go with the metal web joists. So that means that it's better designed to using bespoke software rather than from first principles. So as a designer, you'd contact the manufacturers and provide them with the performance and, if you like, span that you need to cover, and they'll design materials to suit that.
Thanks, Nick.
Cool.
So I didn't introduce Nick. He is chair of the Truss Rafter Association, hence why I brought him in. And Nick, can I ask you to repost your chat, because I think you just sent it to me.
Oh, did I? Oh,
yeah.
no. Okay.
Oh, it's nice. I like you messaging me. It's great. I think we've got another one for so Robert here, because we've got, so how much of the competition has to be offsite and is hybrid acceptable? So I think, Robert, somebody's misunderstanding the terminology between offsite and hybrid. Do you think you could
Yeah, sure. Yeah, so yeah, I know there's the terminologies, etc. I think it's the catch-all is just do things better, more efficiently, you know, the whole build back better piece. But yeah, essentially offsite construction in more industrialized forms, you know, it's about the level of sort of pre-manufacture, as Farmer calls it, with respect to what you're trying to deliver. So you can go for full levels of enhancement, volumetric, you know, internally lined, externally lined, M&E and all the rest of it encapsulated. So high levels of enhancement, fully fabricated offsite, but equally, you know, it can be sub-assemblies and subcomponents which have been, CNC machined, so they slot together on site, so you don't have any loose materials and correspondingly wastage. So both are absolutely acceptable relative to the context. The hybrid piece comes in where you're looking at sort of, you know, combinations of these, or combinations of timber being used with other systems. So this hybrid forms with regards to the tall timber buildings are often mass timber products being used in combination with, say, a concrete core for a lift shaft, or a steel braced frame to provide additional stability. So then it's been considered more as a hybrid form in terms of materiality, but it can equally be a hybrid form in terms of how you constitute the different levels of offsite construction.
Thank you, Robert. So the traditional timber frame, as we know it, is offsite construction. So it can come closed panel, it can come open panel, and I forgot his name, Andrew Carpenter from the Structural Timber Association will be back to talk to us later in the programme. So he'll have some more information for you there.
Yeah. I was just going to pick up, because I think it's interesting, because, you know, UK wide, what is it now, 25 to 30% in terms of timber frame construction for residential new build. The vast majority of that is still what we would classify as open panel construction. So you're probably, you know, something like, you know, 15% of that 30% as such, so 3 to 5%, say, overall, is the higher levels of enhancement. So that's your, you know, your CCG IQ system, or your Stuart Milne Sigma system, which have higher levels of enhancement. So they encapsulate the installation. You have external and internal lining, and often have windows and doors included as well. And with regards to that external lining, you know, moving away, say, from a traditional on-site built brick facade to perhaps a render board and render finish, or even a brick slip, or alternative lightweight form of cladding. And you can do that within the factory, ship it to site, and then it's just about how you join them up, how you stitch them together and make sure it's weather and watertight.
Thanks, Robert. So we've got an interesting question here coming from John Harris. If specifying EWP, so engineered wood products, which are currently not fabricated in the UK, such as CLT, can we assume that in the future, when the Sunderland project is built, there will be such manufacturers here in the UK, so that when looking at LCA, so life cycle assessments, there won't be large carbon costs incurred from importing from the EU? Well, you're leading into tomorrow, where we'll be looking at carbon counting. And for this specific project and this specific challenge, we are asking you to look at materials and manufacturers that are already in existence commercially. So hopefully we'll run this again, and then there'll be other products on the market. So we want you to look at products that are on the market that have their own EPDs. So I hope that answers you, John. Now we've got one in from Richie. Is it best practice for timber to be tannalized when used externally in construction? And how important is this process? I'm wondering who wants to pick this up. Does any of you want to put a hand up?
Yeah.
Yeah. I think the important thing is that design is always more important than preservative treatment. So you should be designing a structure that protects timber in it from increased moisture levels. And it's always better to start with the design and then potentially use preservative treatment only where it's necessary and you can't protect the wood from moisture via any other means. I think if it's in contact with moisture, then potentially softwood timbers will decay. So therefore, you need levels of treatment.
Thank you, Nick. Do you want to add anything to that, Iain?
Yeah, I was just going to say that that there's species that you can consider that are sort of durable. So depending on what you're using it for, if you're using it for cladding, you might look at using larch or Western red cedar or something that is a more durable timber. So the durability does vary. The natural durability of the timber does vary. So you might want to consider sort of depending on what context you're using it in.
Yeah.
Can I come in on that as well, Tab?
Yep. Last one.
Yeah, so just on that as well, just I agree both of them, absolutely, but also look at things like modification of timber as well. So you've got things like acetylated timber, things like a coir, which could be used for joinery products, and that they're generally guaranteeing their products now for sort of 50 to 60 years. You've got things like Kebony, which is I think an alcohol process, which does a similar thing used for cladding, but also things like thermal modification, things like thermowood, which is a softwood thermally modified timber, and things like brimstone, which is a thermally modified hardwood product. Thermally modified non-durable species, hardwood species like ash and sycamore and poplar, I think are the three that they use. And again, that will basically all these processes generally make the timber unpalatable to the fungi and the insects that might want to eat it, and that's basically what happens. And obviously changing the structure of the timber as well, which means it doesn't hold on to moisture as well. So just some other alternatives there to chemical treatments, which can cause an issue at end of life. We've got big problems at the moment with timber from the 1950s to 2007, where some of those timbers are now classed as hazardous when they're taken out of the building. So if you can, like I say, look at detailing, look at durable species, look at other modification techniques before you look at treatment, that would be great, because it helps at end of life.
Thank you so much, Charlie. So you're looking at right product, right species, right place, design for durability, and design for longevity. Let me share screen. And I'd like to say thank you to all our speakers tonight. So thank you, Richard. Thank you, Alun and Charlie and Iain and Robert and Mila. I'm sure they'll all be available to answer chats and hopefully come back and talk to us again. I want to thank you to our sponsors. Our main sponsors are the Confederation of Timber Industries, but Accoya, who Charlie just mentioned, will come and talk to us later in the series. Rosablas will come and talk to us about fixings. Timber Decking and Cladding Association, I know Janet's in the audience tonight. PEFC, thanks Alan and Charlie. ASBP, the Alliance for Sustainable Building Products, later on in the programme. Wood for Good, who were mentioned earlier, and BSW Timber, which also there was a shot of earlier. And tomorrow night, it gets complicated, because even the professionals can't agree on how we count carbon. So chaired by Adam Vaughan, who is the co-chair of the Sustainability Forum in Reba North East, and Joe Jack Williams, who's a LETI volunteer and also an associate at Fields and Clegg Bradley Studio, will introduce FCBS's Carbon Tool, which is an Excel spreadsheet-based tool. Jane Anderson, who's the Director of Construction LCA and our top LCA expert in the country, is going to come and talk to us. And Tim Martell, who designed PH Ribbon for Passive House, will also come and join us tomorrow. And then hopefully all you lot and our speakers will come and join us on Friday for a let our hair down and have a virtual drink, or some of us might have a real drink, but yeah, virtually. And there we go. That will round up our week for the first week of a webinar series. Thank you very much.